Let's take a look at an example problem that involves volume expansion of two different things. So an aluminum tank in the sun is filled to the brim with gasoline. The temperature increases throughout the day from 20 to 35 degrees Celsius. How much gas spills out if the coefficient of linear expansion of aluminum is 24 times 10 to the negative 6 per degree Celsius, and the coefficient of volume expansion is 950 times 10 to the negative 6 per degree Celsius for gasoline. Alright, so we're given our initial volume of the aluminum. So V naught aluminum is equal to 0.85 cubic meters. Since it's a tank, we're going to assume that's also the initial volume of gasoline, so 0.85 cubic meters. Now, we know that V equals V naught plus V naught beta times delta T, and for solids like aluminum, 3 alpha generally is equal to beta. So I'm just going to use this equation twice. So the change in temperature, it goes from 20 to 35 degrees, that's 15 degrees Celsius. So all I have to do here is take my initial volume, 0.85, plus my initial volume, 0.85, times beta, which is 3 times 24 times 10 to the negative 6, or 0.0000024, times my change in temperature, 15 degrees. And if I do that, 0.85 times 3 times 0.00024 times 15 plus my 0.85 is 0.85098. Okay, so V, my new volume, is equal to 0.850918 cubic meters. So my tank did not expand all that much, but you'll notice the coefficient of linear expansion for gasoline is about 30 times more or so, maybe 40 times more than that of the aluminum. So if I go to the gasoline, I'm going to take 0.85 plus 0.85 times coefficient of linear expansion, 0.00095, and I don't have to multiply this one 3 because it is a volume expansion, times the change in temperature, 15. So 0.85 times 0.00095 times 15 plus 0.85 gets me 0.862. Okay, so my new volume is 0.862. Now it asked how much gas spills out. Well, if my tank only expanded to 0.850918 and my gasoline expanded to 0.862, that's clearly a greater volume of gasoline, so the difference between them is going to get me how much gas spilled out. So 0.862 minus 0.8509, 0.8509 tells me that I lost 0.0112125 gallons, or I guess not gallons, cubic meters of gasoline. Okay. That's actually kind of a lot. If we had 0.01 cubic meters, we'd have, 10 cubic centimeters or so. So 10 milliliters, 10 milliliters, 11 milliliters, and that's kind of a lot of gasoline. Now, if you think about that, how much gasoline is it going to take to fill it back up if we wait until the next morning? Well, this volume of gas was lost, but since it contracts when it cools back down, the gasoline is actually going to, just think about that for a minute. Okay, the aluminum tank is going to get a little bit smaller. It ought to return back to 0.85 cubic meters. What is the gasoline going to return to? Is it going to return to 0.85 cubic meters? Well, if I lost this much of it, how much room is left in my tank now, now that it's cooled back down to 20 degrees? Well, I can assume that when it was at 35 degrees, it filled the tank to the brim, so I'm going to go ahead and call that 0.851 cubic meters. So my initial volume was 0.851 cubic meters. Its change in temperature is negative 15 degrees Celsius. Its coefficient of volume expansion is still the 0.00095. So what's my new volume after this change in temperature? So I'm going to take 0.851 times 0.00095 times negative 15, and I get 0.851 times 0.000 .95 times times 15, negative 15. Okay, so 0.851 plus that gets me 0.8388. Okay, so the new volume of gasoline is 0.8388 cubic meters, and if I subtract that from 0.85, then I see that I'm going to need 0.0111 gallons to fill it back up. Now, is that, or not gallons, cubic meters, is that considerably different than this? No, but it is a little bit different. So if I wait to fill this tank up until the morning, I have to replace it with a little bit less gas than I actually lost, which is interesting due to the volume changes and the temperature changes. So a question to ponder: is it better to buy gasoline, which they sell by the gallon, by the volume, on a hot day or on a cold day?